Hi there, and welcome back to Basic Math or Economics. In this video, I want to practice calculating multivariable derivatives through the context of the marginal rate of substitution. So let's actually jump right into this one. So what you're seeing right here is a Cobb-Douglas utility function, where the utility a person gains from this item when they consume goods X and good Y is X to the 0.7 power times Y to the 0.3 power. So just looking at this utility function, we know right away that this person likes to consume good X more than they consume good Y. So we can use this information to calculate all of our possible effects, especially the marginal rate of substitution. We just need to remember the definition of the marginal rate of substitution, and that is just the negative marginal utility with respect to X divided by the marginal utility with respect to Y. So again, we're using the word marginal, and the first thing you should think of when we use the word marginal is we're going to deal with a derivative. Now I know that I need to take the derivative of my utility function because it's a marginal utility, and I need to do it with both respect to X and Y. So I need to do it for both variables. So we need to make sure we calculate this both ways. But remember, this is just an application of the power rule, and it's a very straightforward one at that. So let's calculate for X first. So marginal utility with respect to X. All right, so here's what we're going to do. There's only one term, so X and Y are next to each other, so I don't need to worry about canceling anything else out. So I need to take the derivative of this utility function with respect to X. Now I'm going to do the standard power rule. X is raised to the 0.7 power. So I'm going to take this 0.7, I'm going to put it out front, and I get 0.7x. Now I need to subtract 1 from this. 0.7 minus 1 is negative 0.3. And then I'm going to completely leave y alone. I'm going to treat y as if it were constant in this case. And think of it just as the number 3. We're not going to mess with it. So I'm going to have y to the 0.3. And that's it. That's my marginal utility with respect to x. I can do the same thing for y. I can calculate my marginal utility with respect to y. And this time, I'm going to leave x alone because I'm going to treat it like it's a constant. But I'm going to take the 0.3 from the y, I'm going to put it out front, so we get 0.3, and then I'm going to put the x first, leave it alone, x to the 0.7, y, and again I have to subtract 1 from here. 3 minus 1 is negative 0.7. And that's it. That's my marginal utility with respect to x and my marginal utility with respect to y. So we can put this all together now. So my marginal rate of substitution is negative 0.7 x to the negative 0.3 y to the 0.3 over 0.3 x to the 0.7 y to the negative 0.7. And we can clean this fraction up quite a bit. So this first term, the 0.7 and the 0.3, I can just rewrite that here. Let's go right here. As 7 over 3. Get rid of those decimals. Basically multiply each of them by 10. Now let's take a look at the second term. I have x to the negative 0.3 divided by x to the 0.7. So when we divide exponents, we just subtract the exponents from one another. So negative 0.3 minus 0.7 is negative 1. And so x to the negative 1 is just 1 over x. So I just put x in the denominator right here. Last term, y to the 0.3 divided by y to the negative 0.7. Again, we're dividing exponents right here, so we can just subtract the exponents themselves. So 0.3 minus negative 0.7 is the same as 0.3 plus 0.7, so that's y to the 1 power, or just y. And don't forget your negative sign. So for this first problem, the marginal rate of substitution is just equal to negative 7y over 3x. And that's it. We are done. We've solved it out. So just remember, don't be scared when you see a multivariable derivative. Just work through it as normal, treat the other variable as if it were a constant, and you can work your way through any of these problems. In fact, let's actually make this a little bit harder. So rather than giving you numbers, now I'm going to give you a utility function where x is raised to the alpha power and y is raised to the beta power, where alpha and beta are just numbers. We could say they're greater than 0 if we want to. That would make a lot of sense. But we can use those same rules. Again, we are looking for the marginal rate of substitution, which is just negative marginal utility with respect to x over marginal utility with respect to y. Let's go through the steps again. All right, first, our marginal utility with respect to x. All right, so I need to take my exponent, bring it out front. So I have alpha x, and I need to subtract 1 from my exponent. Well, that's just alpha minus 1. That's it. I don't know what that value is, but I know it's alpha minus 1, and then it's y to the beta. Because we leave y alone. We treat it as if it were a constant. We do the same thing for y. Marginal utility with respect to y. Okay, now I'm going to bring the beta out front. I'm going to leave the x alone. And then I'm going to subtract 1 from the exponent of y. And there we go. See, I don't even need numbers to calculate this. I can put this all together and get my marginal rate of substitution. So that's alpha x to the alpha minus 1, y to the beta, all of that over beta x to the alpha, y to the beta minus 1. And your negative, don't forget your negative, that's important. Then I can clean this up, I can simplify it. So we are going to have alpha over beta for our first term. Then I'm going to have x to the alpha minus 1 divided by x to the alpha. So that's x to the alpha minus 1 minus alpha. So the alphas cancel out, and I have x to the negative 1 power, which again is just 1 over x. So x goes in the denominator. Then I have y to the beta divided by y to the beta minus 1. So that's y to the beta minus 1, but the beta minus 1 is in parentheses. So again, the betas cancel out, and I end up with just y to the 1 power, which is just y in the numerator. And your negative sign. That's it right there. Our marginal rate of substitution in this case is negative alpha y over beta x. And we can see that's solving it generally right there for any possible numbers. So that's all that goes into solving the marginal rate of substitution. Remember when you're working with multivariable derivatives to just treat the other variable as if it were constant. Anyways, that's all for this video, and thanks for watching.